Hi, my name is Atul. I am from Kerala. I am here to take some portions of physical geography. We will start with the physical geography. So, three portions. The first is geomorphology. Then comes the climatology. Then comes the oceanography. Okay. So in geomorphology, we learned about a brief description about the solar systems, right? Then the Big Bang theory, and the other theory related to the formation of the Earth. After that, we learned about different theories with respect to the formation of different landforms. For example, the continental drift theory. Then comes, what is it? Sea floor spreading. Then the plate, tectonic theory. And also we learn certain shorter theory like the convection cell theory. Have you heard about it? By Arthur Holmes. Okay. Then also we learned about the geomagnetism theory, which describes about the polarity change of the entire Earth. Okay. Then we discuss about different landforms. In landforms, the main landform they are the mountain. Then we have the plateau. Then the plains. Fine. So these are the important things that we learned and some of the important locations all over the world. Clear? Yes. Then in climatology, we started with the different layers of atmosphere. What are they? The troposphere, stratosphere, mesosphere, then thermosphere, then comes the exosphere. Fine. Yes. And after that, we learned about the pressure belts. So this is one of the very important topic, pressure belts. Then we learned about heat budget, the solar budget, then the albedo formation. Fine. Then after that we learned about, yes, okay, then we learned about temperature inversion. Okay, it's very temperature inversion, then cyclones, anticyclone, and types of cyclone. Which are they? The extratropical cyclone, which are also called the temperate cyclone, fine, or depression, traveling depression cyclones. Then we learned about the tropical cyclones and the difference between temperate cyclone and the tropical cyclone. Clear? Yes. And after that we learned about, anyone? Very good, very good. Polar vortex, jet streams, fine. See, here we also discuss about different kind of catastrophic events like the earthquake, we have the volcano and the tsunami, then exogenic, endogenic, whatever, that we discuss it in detail. And in oceanography, we have different movements of ocean, water, that is the horizontal movement and the vertical movement. In the horizontal movement, we learn about tides and horizontal movement, tides are. In vertical movement comes under the tides, downwelling and upwelling. In horizontal movement, we learned about waves and ocean currents. Okay, what are two different kind of ocean currents? They are the warm current and the cold current. Fine, yes. And after that, we learned about the ebb, flood. Then comes the spring tide, neap tide. Okay, and different important ocean currents all over the world in the North Atlantic, South Atlantic, North Pacific and South Pacific. So these are the things that we discuss in entire in the physical geography. Okay. So now we will discuss one by one. So first we will start with the solar system. In solar system we know how the entire solar system is being made, and we had started with certain theories like nebular hypothesis. I hope you know what you mean by nebular hypothesis. Fine. And then we learned about the, okay, what does the nebular hypothesis says? You remember, right? What is nebula? Basically, it's a dust of clouds from where different things have been made. Okay, fine, clear? Yes. And then after that we learn certain the binary star theory. So that's not important for the job, I mean for this perspective. the binary star theory. So these were the undergoings for the new theory called the Big Bang theory. And what does Big Bang theory stated? It consists of a very small, tiny particle which consists of very high energy, very high heat energy, everything, and suddenly it started to burst. Okay, from there, a different fundamental particles start to develop, and they again start to merge, which result in the formation of hydrogen, helium gases, which again result in the formation of certain stars. From there, you can find different planets has been formed. So this is the basic thing about the Big Bang theory that we learned. Fine. Yes. And then we also discuss a brief idea about the solar system. We have the inner planet or the terrestrial planet, and we have the Jovinian planet or the gaseous planet. Okay, why the why the inner planet is said to be terrestrial? Because you remember what is happening? The solar flares, it wiped out the entire harmful gases from the surface of that particular 4 planets, and after that we have the asteroid belt, and that solar flare can't go beyond that. So that's why the remaining planet remained as a gaseous planet, and the other it remained as it became the terrestrial planet. And from there we also discussed that how the hot ball Earth, it become a very sustainable or made a living condition for the human beings and other plants and animals. How? What happened? Earlier it was just like a hot ball, and after many years it get condensed, and you can see different harmful gases were there, where at that time oxygen were absent. Okay, and you can find certain harmful gases like you have some amount of hydrogen, helium, you have nitrogen, carbon dioxide, etc., argon, etc. Okay, and what happened? The volcanoes started to occur from the beneath of the earth, which result in the formation of water vapor, that result in the formation of heavy rain throughout the globe, which cool down the temperature and fill the depression of the earth, which result in the formation of ocean. And after many long time, what happened? The heavy mineral, it started to deposit beneath the earth, and which result in the formation of certain proteins called amino acid, and that result in the formation of the first living being and undefined nucleus like prokaryote, and the best example is the blue-green algae. And this development of blue-green algae resulted in the formation of excess amount, in the absence of oxygen or in anaerobic condition, it resulted in the formation of excess number of oxygen all over the atmosphere. So it took a many long time. It took about billions years, about 10 to 25 billion years to make the Earth's surface rich in oxygen. And after that, you can see the first life form is evolved is called the fish. And then the adaptations, the evolution happened, which what the current Earth is looking like. Okay, so this is what the formation of Earth is all about. Clear? Yes. Then, so that's all about the some basic things about the solar system. And we are discussing in the climatology portion that how the atmosphere are being made. Then we have, yes, we learned about Big Bang theory. Then certain theory which resulted in the formation of how the continents are formed, how the oceans are formed, and what is the reason behind the segregation of this continent. Okay, so that the first theory was by Alfred Wegener, and that theory is called so before that I will give you a brief idea that what happened at the earlier stage of the Earth. So at first it was formed into a very supercontinent, the initial state during the archaeological era, and it is called the, not Pangaea, Rodinia. Okay, it is called Rodinia. Rodinia started to break, and again in the Mesozoic era it started to merge again, and that it become a supercontinent called Pangaea. Okay, after that the Pangaea also started to move into different direction towards the south and north, which resulted in the formation of Laurasia and Gondwana. And I hope you know why the name Gondwana, because it belongs to they said that the early belonging refers to that Gondal tribe, Gond tribe. So that's how the Gondwana name it derived. And Laurasia, you know that. And between that we have a piece of water, it is called the Tethys Sea, the now remain of the Mediterranean Sea. It's said to be the present remain of the Mediterranean Sea. Clear? So this is what we learned. And now Alfred Wegener gave the reason that why in his continental drift theory, that how the continental are drifted and what are the observation which proved his theory. The first main theory was with respect to, you remember I think about the jigsaw fitting. You can see if you take the South American continent and if you take the African continent, if you join it, it's just like a jigsaw. It will looking like a jigsaw puzzle. So that was the first observation led by Mr. Alfred Wegener. Then the second observation, he collected the rocks across the coastal areas of different continent, and the rocks were of the same ages. Fine. So that was the second. Then we have the Paleozoic, they collected the fossil and it has the same character. And the fourth one, the glacial evidence. So these are the four observations that led the Alfred Wegener to conclude his continental drift theory. Now, what was the main drawback behind the continental drift theory? Anyone? Basically, here, how the continent is being drifted, the main force is not being described. Okay, but for the for the result, he told that it is due to the gravitational force of the sun, moon, and the earth. And definitely we know the force, the gravitational force is not that much extended to rip off the entire continent. So that's why after that a new theory came which described the reason behind the drifting of this continent, and it is called the convection cell theory. So what do you mean by convection cell? So we know that Earth's interior part, it consists of a semi-molten state called, in the asthenosphere there is a semi-molten state. There we have a cells which used to rotate in different direction. We have an ascending limb and descending limb. Okay, so what will happen? These two convection cell, when it try to rip off, this force will generate to tear apart two different land masses. And I hope you know the reason behind the convection cell, right? Okay, because when we go down, the temperature get increases. So the upper layer will be more cooler. So due to its weight, it will start to sediment, and again when it get heated and again start to move upward. So this cycle continues, which result in the formation of convection cells. And this theory was postulated by Arthur Holmes. Now we got that the reason behind the drifting of continent was the convection cells. So they are different kind of convection cells which are responsible all throughout the globe. Fine? Clear? Yes. And based on that, before that we also discussed about the interior of the earth, right? Okay, the interior of the earth. So what are the different waves that help us? So we have the direct evidence and the indirect evidence which determine the interior of the earth. Okay. So based on that, the most appropriate method that show us the interior of the earth was the movement of primary waves and the secondary waves. So I hope you know what are the primary wave and secondary wave. They are said to be the body waves. These are the waves which is generated inside the body of the earth. Okay. So primary wave is more faster as compared to the secondary wave. Clear? And primary wave can travel both in solid and liquid, but secondary wave can't pass through the liquid. So these are the things that you have to note it down. Clear? And what happened and how this primary wave helped to find out the interior of the earth? You know what happened? We have different layers inside the earth also, right? We have the lithosphere, then we have the asthenosphere, then we have the mesosphere. See, we have another mesosphere in atmosphere, but this is also called the mesosphere. There's another layer called barysphere, not that much important. So collectively mesosphere is said to be the interior part. Okay, and also you have heard about different kind of discontinuity. What are they? We have the Conrad discontinuity, we have the Moho discontinuity, then very good, Repete discontinuity, then we have the Gutenberg discontinuity and the Lehman discontinuity. So these are the different kind of discontinuity, and I hope you know what discontinuity. When the wave passes through different layers, what will happen? Due to the density, change in density, the waves start to have some kind of deviation, and that point where there is a deviation is said to be a discontinuity part, and it is being divided into different kind of name. That's it. Clear? Yes. And now we know primary wave. The primary wave, it travels faster in the lithosphere, but when it reaches the asthenosphere, the speed get reduced because it shows that the asthenosphere is of a semi-molten state, not a liquid state or not an entire solid state. It's just a semi-molten state. Okay. So that's why you can see the speed get reduced in the asthenosphere region. Again, when it enter into the mantle region, the speed a bit increases, and when it reach into the outer core, what happened? It reduced drastically. So it shows that the outer core is made up of a liquid kind of material. Fine. And then when it entered into the inner core, the speed was the highest. So it means that solid, the inner core is made up of a very solid hard material. So that's what the Nife, the Sial, Sima is all about. Okay, and I hope you know Sial. It is made up of the continental crust, and the entire mantle region, the oceanic crust, and is made up of Sima. Fine. So this we discussed in detail in the previous lectures. So these are the things that you have to keep in mind. Clear? And what happened to the secondary wave? So secondary wave, it moved through the lithosphere. It also moved to the asthenosphere. So one thing is confirmed, that the asthenosphere is not made up of a liquid kind of thing. It is just a semi-molten kind. But when both the waves started to move in that region, what happened? The speed get reduced a lot. Drastically it reduced. Now it was able to move in the outer mantle, inner mantle, but further there was no movement. So that's why you can see the shadow region of the secondary wave. So this is the shadow region where you can't find any kind of output. In this all region you can find the output of the secondary wave. Okay, so this much amount of about 104 degree, you can see there is the shadow wave of secondary wave. But in the case of primary wave, you can see the shadow wave is very less. But 140 degree and 100, only some shadow waves zone will be there. Other you can find the movement of the primary wave. And you know the energy or the vibration from where the point start is called the focus, and the nearest distance of the surface of the earth from the focus is called the epicenter. Clear? So these are things that you have to keep in mind. So this is a brief idea of interior of the earth. Fine? Yes. Then we have we discuss about continental drift theory. Then we discuss about the convection cell theory. Fine? Now another theory which led to which mixed up with the convection cell, which describe about the MOR. So what is MOR? It is called the mid-oceanic ridge. Very good, very good. So what do we mean by mid-oceanic ridge? And the very interesting thing is, as you know, that when does this sea floor spreading theory start to know more, when it get to familiar more? After the Second World War. Why? Because after the Second World War, you can find invention of different submarines. And when the submarines start to move throughout the floor of the oceanic floor, then they came to know that there are huge amount of landforms inside the interior of the sea. In the same way, have you heard about how the jet stream is being invented? So we don't have any idea of jet stream before 1945. Okay, so when the Americans started to move through, to put the bomb in the Pearl Harbor region, there was a very interesting phenomena. So they were trying to travel over the subtropical region. But what happened, due to the excessive jet stream, the speed of the jet stream, it cannot get into it. So that's why they came to know that some force is there which is denying the movement of that flight through that particular region. So from afterwards, we came to know about the formation of jet stream. I mean, jet stream is there for a very long time, but this is the period when the scientists came to know that something is there. So that's how the jet stream is. So that's why we don't have any idea of jet stream before 1945. So the World War also changed. So as we all know that the necessity is said to be the mother of invention, the same thing. Every situation forces us to invent something. The same way what the geography all just defined. Okay, yes. So we have different structures, and a very important structure is the mid-oceanic ridge. And I hope you know what is mid-oceanic ridge. You can see the activation of convection cell, from where you can see the lava is being generated. Not lava, magma is being generated, and when it reaches surface, it will form into lava. Fine. So these are terms that you have to keep in mind. And one more thing, the oceanic crust is mostly made up of basaltic material, and I hope you know the character of basalt material. Yes, what is the character of basalt material? It is very highly flowable. It is less viscous. Fine. Okay, and the continental crust is made up of antiseptic, granite antiseptic material. Okay, and what is the specialty of granite and antiseptic material? It is more viscous. Okay, that's why it's very dangerous. This kind of the volcanoes coming from the burning of the continental crust is said to be more dangerous, because it traps certain gases, and that pressure increase result in the bursting of that particular lava, and that could be very dangerous. Some of the examples I already discussed about the Vesuvius volcano, the Stromboli volcano, etc. Okay, yes. Now, so this is what you can see, the emergence of the magma, and now you can see when you go away from the mid-oceanic ridge, what will happen? The age of rock, you can see it is increasing. That is, we can find the younger rocks near to the mid-oceanic ridge, and when we move away to the coastal region, what will happen? The age of rock start to increase. Why? Because as I said, when the convection cell get activated, the lava, it pushes the rock near to it, and that continues for a very long time, which result in the formation of this aging of rocks. Okay, so this was described by that's what it is called, sea floor spreading. Okay, the floor of the sea is spreading through these convection cells. So that's how the landform is made. And one more thing, in ocean, if you see the ocean topography, the landform is made in the mid-oceanic ridge and is destroyed in the trench. Why? Because you can see when this moves, when the lava pushes the rocks, that rocks will start to subduct into the continental crust. So when it starts the subduction, the gap between the subduction is said to be the trenches. So you can't find any trenches, because trenches are said to be deepest point. So definitely you will think that trenches would be in the center of the ocean. No, you can't find any trenches in the center of the ocean. They are found in the region where the junction between the continental crust and oceanic crust. So that's why you can see the Mariana Trenches. It is near to the Mariana Island. Okay, you can see the Pacific plate is being subducted into the Mariana Island. And the junction, so suppose this is the oceanic crust, this is the continental crust. So when it gets subducted, so this gap is what is called as trench. And the ocean topography, it created in the mid-oceanic region and it destroys in the trench. So this is what the basic understanding about the sea floor spreading is all about. And now what was the main drawback of the sea floor spreading? Because it doesn't describe, it only focused on the oceanic topography. It doesn't discuss that how the how the mountains are formed, what is the reason behind the formation of plateau. Okay, and then also he doesn't describe about the different catastrophic events, that what is the reason behind the earthquake, or why the volcanism, why certain volcanism cause island and why certain volcanism cause mountain, a big mountain with a high dangerous eruption. Okay, so that thing is being described by the which theory? No, after sea floor spreading, the plate tectonic theory. So this is said to be the most acceptable, most advanced theory which has described all the doubts regarding the formation of all the geomorphological structure in the earth. Okay, so we in the plate tectonic theory, guys, it is divided into three different categorization. One, it is called the divergence theory, right? Then we have the convergence theory. Then we have the transform boundary. Okay, so divergence, convergence and transform. In divergence, so what kind of force we can see? We can find the tensile forces. You can see here what is happening. The ripping off of two different continents. Oceanic crust or the continents. And there we describe about the formation of Rift Valley. Okay, you remember the Great African Rift and how it is connected with the different part. One, it is connected with the Red Sea region, and how it is connected with the Gulf of Kambat region. So any disturbance, any formation of divergence will result in the formation of earthquake in the Bhuj region. So that's what happened in 2001 Bhuj earthquakes. Okay, so wherever you can find the divergence, it have the two results. One, definitely due to the disturbance, due to the energy release, there will be a earthquake. And second thing, they will have a volcanic eruption. So these are the two things which is responsible for this kind of things. Fine? Any doubt? Clear? Yes. Now, then second we have, now what are the example of some of the divergence? What are different example of some divergence? One thing, how the Red Sea is being formed. Earlier it was a rift, then it become a nascent sea, and then it is said that now it will become an ocean kind of thing. So that's what this system is all about. So after many billion years, it said after 10 billion years, what will happen? The Red Sea will become an ocean. the Rift Valley become a, the Rift Valley become a, okay, the Rift Valley will become a nascent, see, and it continues. So you can see the African continent will split apart. Okay, so this are thing that you have to keep in mind. Clear? Yes. Then we have the convergence theory. In convergence theory, we have three type of convergence. One, we have ocean convergence. In ocean convergence, it describes about the formation of volcanic island. The best example, you can see the volcanic island formed in a tropical region, the Java Sumatra region. You have this Hawaii region. Okay, so these are the best example for the ocean convergence. So what is ocean convergence? In ocean convergence, we can find two different kind of oceanic plate. So we know both of them have the same density, but the plate which is lengthier will get subducted into the other plate which is shorter, and that will, and what will happen? And one more thing is, what is specialty of this oceanic crust? It is highly flexible. Okay, it is very flexible, and it has the capacity to get intruded into that particular region. Okay, and what will happen? So here it will get heated, and basaltic eruption, this will also get heated, which result in the formation of volcanic islands in that particular region. And since it is a basaltic eruption, what will happen? It won't form any peaky kind of thing. It will flow over it, that result in the formation of volcanic island. And that's why you can see the volcanoes of the tropical region are said to be very peaceful and calm. The Anakrataku, these are the best example. They are very peaceful eruption. You can't find any kind of death in the, if you want to dive over it, then you will die. But it won't have the, big explosions kind of thing. Okay, and you can see the evacuation is very less in this particular region. Okay, yes. Then second, we have the ocean continental convergence. Okay, you have to mark the places in your map. Okay, the Hawaii, we have the hotspot island, the Reunion Island, then Aleutian Island, then we have the most of the archipelago. Okay, the different kind of islands, the group of islands, the Chagos. These are the example for this ocean convergence. Then we have ocean continental convergence. What will happen? We have an oceanic crust, we have a continental crust. Which is more heavier? Definitely the oceanic crust. So which the heavier one will get subducted. What will happen? It gets subducted, yes, due to flexibility, due to the excess heat in the interior of the earth. What will happen? It will burn, and this will have basaltic eruption, and this basalt will result in the melting of this continental crust. And what is the continental crust made up of? Andesitic, which is highly viscous. So again you can see, since it is viscous, it will get solidify, and that why it result in the formation of peaky mountains, result in the formation of sills, where you can see the continuous eruption of the magma or volcano. And one more thing, since it is very viscous, here you can find the very explosive volcano. Why? Because since it has very high viscosity, the gases get trapped into that particular volcano, and that will result in the bursting or high eruption of this particular region. The best example is the example for the ocean continental convergence are one, the Andes. So that's why it is called andesitic. Eruption is andesitic. So that's why the name Andes is being derived in the South American part. And you have different example, the Mount Aconcagua. Okay, the biggest peak, and then we have the Rockies are in the, I mean speaking about the volcanic mountain in the Andes region. Okay, Chimborazo, okay, Chimborazo, etc. These are the example of the volcanic mountain in that Andes region. Then we have the Rocky Mountains. Okay, then the what other example? Atlas Mountains. So these are the example where we can find the ocean continental convergence. Clear? Where the ocean and continent get when the ocean get submerged into or subducted into the continental crust. And in ocean continental convergence, we can find the presence of earthquake and also the volcano. Fine. Okay, good, perfect. Now, and third one is the continental. So what's specialty of the continental convergence? Here we can't find any eruptions. Okay, why? Because both the specialty of the continent is, the continental crust is, it is highly brittle. It is not flexible as compared to the continental crust. So when it gets subducted, it gets breaked off. So when it breaks off, what will happen? There will be no heating, so that's why there will be no eruption of volcanoes. But you can have an experience of very dangerous earthquake. Okay, so we can find more dangerous earthquake in continental region as compared to the other convergence. Fine. Now, what are the best example? Himalaya. Then we have the Ural mountains. So these are the Alps. So these are the best example for what we can describe as the continental convergence. Fine. Any doubt? And I hope you know how the Karakoram, what's the difference between Karakoram is said to be once a volcanic mountain. So that's why it's called Kara, black in color. Why? Because when India was moving into the Eurasian plate, what happened? Earlier, the Karakoram, first it was not a part of Himalaya. You remember what happened at that time? So there was a mountain ranges in the Eurasian plate. Fine. So Indian plate was here at that time. So he was enjoying a tour with a Reunion Island there, having the basaltic eruption. Okay, no issue. Then we have a oceanic, crust. So due to this oceanic crust, there led the formation of volcanic mountain. So that's why you can see the Karakoram. It is black in color due to that eruption, andesitic eruption. And when then the Indian plate reached into the, had a contact subduction with the Eurasian plate, then what happened? Then it resulted in emergence of Himalaya. So that's why there is no volcanic eruption in the Karakoram region, and definitely there will be no eruption in the Himalaya because it is the result of continental convergence. Okay, and it is also called the third pole of the world. Clear? So these are things that you have to note. And then we have the transform boundary which result in the formation of block mountains. Okay, not only block mountains, you can also find certain faulty region, the San Andreas fault in the California region. So these are the examples. So this is how the tectonic plate tectonic theory explains the formation of different landforms all over, different geographical structure all over the world. And with respect to that, we learned, we also completed the different landforms, the mountains, okay, the block mountain, then we have the fold mountain. So the convergence mostly result in the formation of fold mountains, okay, and then it transform, it result in the formation of block mountains. And block mountains, we know the formation of host and graben, which is the high region, mountain region, and we have the rift region. The best example is the Vindhya, Satpura and the Narmada where it is flowing. Okay, fine. Then also we learned about the Colorado River, the Great Canyons and all. So these are structure that you have to keep in mind. Fine. Yes. Then we have the plateau region. What are different kind of plateau? Have you heard about intercontinental plateau? What is, sorry, intermountain plateau? What is intermountain plateau? The plateau form in between a two mountain. Sorry?
The word dune.
Dunes. Okay, fine. Okay, so intermountain plateau, Anatolia plateau. Have you heard about it? Okay, so these are the example where, and now you can see certain kind of mineral deposition. Okay, because you can find the sediments from the mountain, in the two mountains, and that result in the formation of, okay. Then we have the continental plateau, the lava plateau. What are example of lava plateau? The Deccan plateau. Okay, due to the basaltic eruption, and I hope you know why the basaltic eruption in Indian continent at that period. Okay, due to the hotspot mountain from the Reunion Island during the northward journey of Indian subcontinent. Okay, fine. Yes. Then the glacial plateau. The best example is the Garhwal plateau. Okay, so these are the different type of plateau that we can see. Okay, so that's all about the different landform. Then the plain area, and I hope we discuss in detail the all plain area of the world, starting from the Indus region. Okay, in the Po, Danube, then we have the Yangtze, Yukon. Okay, then Mississippi, Missouri, Murray, Darling, everything we discuss in detail. Okay, we mark these certain capital cities. Okay, and Dniester, it's very, very important where Dniester river is situated in the Kyiv. That is very, very important. Why? Due to the Russia-Ukraine issues and all. So just have a look into it. Okay, yes. So that's all about and then we learned about the catastrophic events, the reason behind the earthquakes. Fine. The epicenter focus and how the earthquake is formed. The two different kind of wave. We have the body wave and the surface wave. Body waves are the waves which is created in the interior of the earth, and that divided into two. That is the P wave. Very good. P wave and the S wave. This time a question was asked directly. Okay, which will reach first. And one more thing, P wave is represented as longitudinal wave and S wave is represented as a transverse wave. Okay, one will have a to and fro motion, another will have a just like a water ripple. One will act as a sound wave, another will resemble as a, you can see the water rippling kind of thing. Okay, the S waves. So these are the things that you have to keep in mind. Fine. Then we have the volcanic eruptions. We learned about volcanic eruption, the reason why the Japan is very sensitive for earthquakes and all, and also why Mediterranean region is very famous for volcanic eruption. Why? Because it is made up of different, it's a formation of different multiple plates. You can see a smaller multiple plates, so it undergo frequent interaction, and that frequent interaction result in the formation of earthquakes. Fine? Clear? Any doubt? Yes. Then we learned about the tsunami, and I hope what is the difference between a wave and a tide? Please never ever get confused. The wavy thing that you can see in the seashore, it is not a tide. It is basically a wave. And what is wave? How is wave is formed? Due to the combination of the wind and the gravity. Wind will push the water through the surface and gravity will pull it, and that how the waves are formed. And what happened in tsunami? Suddenly the wavelength of the wave get increased, and when it start to reach at the shore, what will happen? In order to control this wavelength, it will when the wavelength is increased, in order to maintain the stability, accordingly it will also increase its amplitude. So that's why you can see it will, at the first time it will pull the entire water towards itself. So that's why you can see before the tsunamis, you can find the entire water start to get back from the coastal region. Okay, fine. Yes, and that's why you can see a vessel in between the sea is more safer as compared to the people living in the coastal region, because we won't have that much amount of experience during when we are in the center of the sea or ocean or water body, whatever it is. Okay, fine. So this is what the tsunamis, and we just had some tsunami mitigation and all, and that is basically very important for your disaster management GS3 perspective. Fine. Okay, just have the mitigation ideas. It's a very simple thing. It's a very small portion. Fine. So that are the catastrophic events, and that is all about the geomorphology portion. Clear? Any doubt?